Hello, La Belle Air students. Hi, it's Mr. Avant, and guess where I'm at? I am at La Belle Air with our old classroom. I miss my old big board where I could write on. I am in the process of picking up all the pieces and throwing away stuff and putting stuff away for the summer, and looking forward to next year. But here we are. I am going to do my live lesson here from school today, but if you did not catch it or you need some extra time with some of the teaching that I'm doing for this, then please enjoy the video. Watch the whole thing. I'll go over the problem set as well. So today what we're going to focus on is comparing decimals. What we've done over the last 3 lessons is I've taught you what a decimal is, what is the place value of the decimal. We know that there's a decimal point, and that on the left hand side of the decimal point are the ones and tens and so on that way, and then on this side we have tenths and hundredths. That is represented as a fraction as well. 1/10 and, excuse my phone please, 1/10 and 100. So this would be 1/10, and the second place is 100ths. Okay? Hope that doesn't confuse you with the 0 here. But today what we're going to do is we want to start comparing decimals, because it gets a little tricky when students are used to looking at values of numbers, and when you're on the right hand side of the decimal point, things are different. When numbers get bigger on the right hand side of the decimal point, things get smaller. So values get smaller. So let me give you an example to show you how tricky that can be. All right, let's look at 0.11 and the decimal 0.7. Okay, most students when they're looking at decimals for the first time go, well, this 11 looks bigger than this 7, but wait a minute. What we have to be concerned with, I'm sorry, let's make this 0.07. Okay, what we have to be concerned with is what is the value of the number in its place value. So if we were going to look at these as fractions, 0.11 really says 1/10. Let's break that down, the number bond. That really says 1/10 because the 1 is in the tenths place, and this is saying 100th. Okay, that is very different than just saying 11. So let's go over here at this 0.07. The 0 is saying no tenths, and the 7 is saying, whoa, that is 700ths. Okay, so remember, if we're comparing fractions this time, the hundredths are much smaller than the tenths. Let's look at the number line. Okay, so I made a number line much bigger on this board so you can see this. But we have 0 right here and 1 over here. So everything is between 0 and 1. And we can even think of this as a meter, as length. Okay? Let's just say that this is 1 meter long. Now, in between the meter and the metric system, we have tenths. And that's perfect for demonstrating decimals. So we have tenths. So there's 10 parts, or 10 out of 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I put the fractions above it. 1/10, 2/10, 3/10, 4/10. You get the idea. 5/10 is halfway. 5/10 is the same as 1/2, or 0.5. So look below, I have the decimals that match it. They're all in the 10th place value. 0.1, 0.2. 0.1 is 1/10, 0.2 is 2/10, 0.3 is 3/10. Hopefully you get the idea. Now, in between the tenths are the hundreds. So from 0 to 1, there are 100 hundredths. So I could add that over here too. 100 over 100. The hundredths are in between the tenths. There are 10 hundredths in between each tenth. So now we have a completely different situation here. We say 11 hundredths or 1/10 plus 100. Let's also put that there. 11 hundredths equals 1/10 plus 100. And over here we have 7 hundredths. Now we have to decide which one is bigger. So let's try to plot them on this number line. The number line is going to give us a length, and we want to determine which one is longer or shorter, and then we'll give it one of these symbols. Okay, so I start off by looking for my 1/10, because this one is a 1/10. Here's 1/10 right here. And then I need to go an extra 100th. So if I'm looking at it right here, this is where 1/10 plus 100 lives. This is where it lives, okay? So this is where 0.11 is right there. Way at the beginning over here. Now, where is 7 hundredths? Well, you would think, well, that's 7 is way over here, but no. 7/10 is over here. But 7 hundredths is actually 1, 2, 3, 4, 5, 6, 7. 7 hundredths is actually right there. So let's look at it as length. So this one is this long, and this one is this long. The 11 hundredths, or the 0.11, is bigger than 0.07. So I would put a greater than symbol. Greater than is comparing the left to the right. So the left is bigger than the right, or longer than the right. Okay? It gets a little tricky, but once you get the hang of it, you need to know that the tenths are bigger than the hundredths whenever you're comparing tenths and hundredths together. Let's look at another example real quick. Let's look at let's look at 33 hundredths and 0.09. Okay, so 33 hundredths and 0.09. Let me get rid of this right here too, so we don't get confused. Okay, where is 33 hundredths? Well, 33 hundredths is actually, if we break it down, 33 hundredths is 3/10 plus 3 hundredths. Okay, and 9 hundredths is simply 9 hundredths. This is in the hundredths place. It's the second place from the decimal point. The 9 is in the hundredths place. Get used to that. Okay, so let's look for 3/10 plus 3 hundredths. Here's 3/10, and then 1, 2, 3. It's right there. Let me get red. 3 hundredths is right there. So this is 3/10 plus 3 hundredths, or 33 hundredths. Where is 9 hundredths at? Well, it's less than 1/10. There's no tenths here at all. So it's got to be before 1/10, and it is right here. There is 0.09. Therefore, this 33 hundredths is much bigger than the 9. So again, if you're comparing 3s and 9s, these 3s, or the 3/10 is much bigger than the 9 hundredths. So this would be greater than. All right, let's look at one more today. Okay. Okay, last one here. Let's compare hundredths to hundredths. When you're comparing hundredths to hundredths, it's much, much easier. So if I say 57 hundredths, or we could say 57 cents is another way of looking at it. Is it bigger than 82 hundredths or 82 cents? Well, if you think of it as cents, definitely 82 cents is bigger than 50. There's more in 82 cents than 57 cents. But let's break that down to help us find it on the number line. This would be 5 tenths because it's in the tenths place, and this would be 7 hundredths. All right, this would be 8 tenths, and this would be 2 hundredths, just by looking at their place value. All right, let's see if we can find it on the number line. Here is 5 tenths. 5 tenths is right in the middle. Then I have to count 7 more. 1, 2, 3, 4, 5, 6, 7. There it is right there. 0.57. And 82 hundredths, I have to look for 8 tenths first. There's 8 tenths. And then 2 more hundredths puts me right here. 0.82. Okay. Which one is bigger? Naturally, this one's going to be bigger. 82 is bigger than 57. When you're comparing hundredths, you can compare them almost by value without the decimal point. So we need a less than symbol to say that 0.57 is smaller or shorter than 0.82. And we can also think of it as meters too. Well, I hope this helps you. The next section you're going to see is about the problem set. I'll go over the problem step by step to help you finish it. Please watch the videos. Please watch the live meeting. Please do all of your problem sets in your morning work, and you'll be better off. Bye. Okay, here we are, lesson 9 problem set from module 6, and we're getting down to business here. Let's take a look at number 1. It says, express the lengths of the shaded parts in decimal form. Remember, decimal form. Decimal form. Write a sentence that compares the two lengths. Use the expression shorter than or longer than in your sentence. So what we're doing here is that we're, instead of using greater than and less than, we are trying to give you the idea that this is in a measurement form. So if you can imagine a decimal being bigger or smaller, imagine it being longer or shorter. So let's look at A. We need to figure out what the measurement is. What is a decimal right off the bat? So you can see that it's expressed. Let me zoom in a little bit. It is expressed in meters. So we have 1 meter and we have parts of a meter. So imagine that this is 0 over here, and this is 1 meter over here, and there are 10 parts in between. So we're talking, remember, we're talking about our tenths and our hundredths here. So we're looking at tenths. I see 1, 2, 3 shaded areas. So let's go ahead and give this a fraction and a decimal. It is 3 tenths, and we can also call that 0.3. Remember that the first place after the decimal is the tenths place. Okay, now let's look at the second one. We have 1 meter again, 0 to 1. And now I see that we did that little trick where we took one of those tenths and broke it up into more tenths. Now this might be hard for you to see, but I'm counting 1, 2, 3, 4, 5, 6, 7. 7 out of 10 in one of these tenths. So what would that make that? If these were all broken up into tenths, if the tens were broken up into tenths, that would be 10 times 10, that would be hundredths. So in this third tenth here, we're looking at hundredths. And I see 7 of them, 7 out of the 100. Okay, so we have 1/10, 2/10, and 7 hundredths. if we put 2/10 plus 7/100, we end up with 27/100. Okay? And it's easy to convert that into decimals because the 2/10 goes in the tenth place after the decimal. So here's my decimal. Here is the 2 in the tenth place, and then 7 in the hundredth place. So you can easily see that that's 27/100. Now, look at the distance. So let me use a line to show you where the shaded area stops. And here is a line here that shows where 3/10 stops. So 27/100 stops here, and 3/10 stops here. You could also consider 3/10 as being 3. Oh, I need to go ahead and give that. Go back to draw. I can consider that 30/100 as well. Just put a 0 after that 3 in the tenth place, and now I have 30/100. They mean the same thing. Hopefully you're starting to get that idea. But if I'm looking at length, the 30/100 is longer than. So I'm going to put longer than right here. All right? Okay, so that explains this one. So you need to try that again with B. Look at which one is longer and see if you can give it the right name. So that, again, it's in tenths and hundredths. This one is going to have 1, 2, 3 tenths, plus look at your shaded area for the hundredths. And this one is going to be 1, 2, 3, 4 tenths, or 40/100. So figure that one out on your own, and then list all 4 lengths from least to greatest. So you're going to take this one, this one, this one, and this one, and try to list them from greatest. From least to greatest. Okay. All right. Number 2 says examine the mass. Remember, mass is a measure of weight, or the amount of substance. We're talking about weight here, really, if you want to put it in simple terms. Examine the mass of each item as shown below on the 1 kilogram scale. So if you look at your scale, I can blow that up even more. If you look at your scale, it starts at 0 and goes all the way around and stops at 1 kilogram. So in between are the tenths of a kilogram. So the first one, you put an X over the items that are heavier than the avocado. So the avocado is 0.2 kilograms, or 2/10 of a kilogram. And look where it's at on the dial. Now if I look at the dial here, I can see that it is less than 2/10. This is 1/10 plus 2/100 plus 2/100, and that equals 12/100. And the 12/100 is below 20/100 or 2/10. So I need an X on this one. Oh no, I take that back. Let me undo that. No, this is saying it's less. This says put an X over the items that are heavier than the avocado. All right. Well, this one says 0.6. That's 6/10. And look, it's way over there. So the bananas get an X. And the grapes. And we can also look at the size of this too. It's got to be heavier than the avocado. This one says 6/10 plus 1/100, or 61/100. And it is just bigger than 6/10. And it is way bigger than 2/10. So the grapes get an X too. All right, see if you can remember how to do that when you do the problem set. Let's move over to the second page. All right, on the second page, we are going to express the mass of each item on the place value chart. So express the mass of each item on the place value chart. So you're going to have to go back to the previous page and look at your masses. So the avocado was 0.2, 2/10, and the apple was 0.12, or 12/100. So that is, oh, I need to put a point there and a point here. So that is 1/10 and 2/100. The bananas were 6/10. So, and we could also call that 60/100. We could call this avocado 20/100. And then the grapes were 6/10 plus 1/100
or 61 hundredths. You got to get used to thinking in that way. Okay, there's no ones here. So it says express the mass of each item. Now, complete the statements below using the words heavier than and lighter than. So I want you guys on your own to tell us, is the avocado lighter or heavier than the apple? That should be fairly easy. Now, number 3, it says record the volume of water in each graduated cylinder on the place value chart below. And on the place value chart below, you need to look at these cylinders. There's cylinder A, B, C, D, E, and F. And we need to look at the decimal for the liters. So on A, I'm looking at my liters here. This is 1 liter at the top. Let me write that here. 1 liter. That's really tiny for you guys to see. I can barely see it myself, but there should be 10 or tenths in between 1 liter here, and you want to count how many you see. So I see 1, 2, 3, 4, 5, 6. So cylinder A is 6 tenths. Okay, that's how you're going to fill it out. Cylinder B is 3 tenths. Cylinder C is 1, 2, 3, 4, 5, 6, 7, 8, 9 tenths. Okay, all right. And cylinder C looks like 8 tenths. Oh, wait a minute, what did I do? Okay, C is 9 tenths. D looks like it could be just below. So we're going to call that 0.98, something like that. And E looks like just below 2 tenths, so let's call that 1.18. And then F looks like almost 0.50 or 5 tenths or 50 hundredths. Let's call that 0.48. Now over here you're going to use the greater than, less than, or equal sign. And you want to look at these lengths or the height of the graduated cylinder fluids to know what to put here. So is 9 tenths taller than 6 tenths in the graduated cylinder? Yeah, it is greater than. Is 48 hundredths bigger or smaller than 6 tenths of a liter or 60 hundredths of a liter? No. If I'm looking over here, here is 0.48, and over here is 0.6. It looks like 0.6 is higher than 0.48. So that would be less than here. And C, 0.3 is 0.3 or 3 tenths liters bigger than 19 hundredths or 1 tenth and 9 hundredths. Let's see. Or we could say, is 30 hundredths bigger than 19 hundredths? Sure. I think so. So let's find, okay, here is, I think this would be the 30 hundredths. And I think this would be the 0.19 right here. It is definitely taller. Now for D, I want y'all to try this on your own. It says write the volume of water in each graduated cylinder in order from least to greatest. So you would do that with letters. I think the smallest one would be E, okay? And I think the biggest one would be D. So just try to put them in order that way. All right, that's it for this problem set. Remember, this was all about putting your decimals in order on a number line or a scale or this cylinder chart here. This is a way for you to understand the difference between something like 3 tenths and 9, like this 97 hundredths. It looks like the 97 hundredths is bigger than something that might have a 0 in front of it. You have to pay attention to which place value that number is after the decimal point. I hope you practice this. I hope you watch my live lesson. Good luck, and I'll see you next week, our last week of school. Bye.